Hey everyone, today we have an Autel Maxisys automotive diagnostic scan tool, and the problem with this is nothing at all. But here we have the interface that you plug into the vehicle that wirelessly connects to the tablet, and this doesn't work. So I've had a bit of a look, and initially I thought, because what would happen is the lights on the end, they would, other end, there's a row of lights there, they would stay on when they should come on and then go out pretty quickly, followed by a beep. And initially I hit it with a freeze spray and it would work, and I thought that's interesting, so I tried to reflow the microprocessor. No change, so I ordered a new microprocessor, put that on, no change, so I hit it with some freeze spray again, but I froze the NAND flash chip instead of the processor. Well, actually I tried the processor, but I tried the NAND flash chip. The processor was new, so don't worry about that, and it booted. So, and then when it warmed up it would stop, you freeze it again, it would boot. So I've concluded there is a problem inside the NAND flash chip. And here's the unit out of the case, and the NAND flash goes in here, which I have removed. And it was a long time coming, but finally got the blank NAND flash chips, and we can have a look at using my new XGECU EEPROM programmer. Now, another small hitch that I found is this. I thought I'd looked, but obviously not, but this particular NAND flash is not on the list of supported devices in the software. However, a little bit of research and some data sheets, and I seem to have found an option that should work. Some slight timing differences. Suffice to say that the one in the list has a was a read speed. Hang on. What have we got there? Oh, a page program time of 100 microseconds longer. So this chip out of that we're using is rated at 200 microseconds, and the profile that I'm using is 300 microseconds. I guess that just means it will wait a little bit longer, and we know that since this chip operates faster, it's going to be done. We'll find out. So here's a look at the EEPROM, the TS-1640 IC adapter, and I'll just grab my original, and it's quite interesting how these work. So you push the sides down and you can see the little legs retract, and then you just pop your chip in, making sure there's no fluff on the pins. I'll just get rid of some of that. But a little temperamental. Everything needs to be perfectly clean, I've noticed. And practicing for this, I've had to give the pins a bit of a swab with some alcohol, and then they eventually work. Whether it's just a case of them not making contact to start with, or I don't know, there's obviously various qualities of these sockets out there. So that just sits down on there, and then when you release it, the fingers come over and grab the pins. So and that usually works. Oh, we'll plug it in and see what it does, making sure, of course, we've got down the bottom here our number 1 in a circle. That's pin 1, so we've got our dot on the chip there. Pin 1 must be aligned. I have put one in backwards inadvertently. It didn't kill it. It's a little smart. It does a pin test first. Okay, so hopefully this looks nice and sharp. I think I found the problem with the OBS software settings that I had. Actually, if you guys want to see, the setting that I went to was under video, the downscale filter I had on, I can't change it while I'm streaming, but it was the center one, so I've upped it to sharpened scaling, and yeah, that made a difference. So there you go. So the chip that is in this device is a Hynix H27U1G8F2BTR, and that is a 1 gigabit 128 meg times 8-bit chip with 2K plus 64 bytes of in your cell array there. Block size 128K plus 4K spare, and the one that I'm gonna go for is this one. No, that's the wrong one. This one, which is a HY27UF081G2M, which is basically the same, 2K plus 64 bytes, 128K plus 4K spare. So hopefully it will be sufficient. We've got random access time of 25 microseconds on the original chip, sequential 25 nanoseconds, and page program time 200 microseconds. And over here we've got 25 microseconds, 50 nanoseconds, and 300 microseconds. So within a few nanoseconds. It's the best I can come up with at this point, unfortunately. So we shall mosey on. So we've got our original chip in, and if I go device read ID, it comes up here. So the pins must be connecting sufficiently to be able to do that. So then down the bottom we've got our image file, and that's the file name we're going to save it to, and I'm going to hit it with some freeze spray before I read it. Right, so let's chill this thing down a bit and be prepared to read. Device read. Okay, give it time to freeze. Cool. Read. Reading. I may need to give it a squirt halfway along if it starts to cool off too much, because I don't know. Shame I can't have a temperature probe on that while it's going. 20%. Just hope any condensation there is not going to interfere with the pin data. How cold is that? Oh, the case is pretty cold. 40%. Lucky it's not too far in the day. She's not she's going to be a hot day, but pretty cool at the moment. 55%. I wonder where the data is on this chip. that's better. Starting to run out of active ingredient. Okay, 70%. I don't know if they've used the full data capacity of this thing. But we'll keep going. It boots pretty quick. Like it really does. It's you turn it on and then beep and she's away. So it's probably only a little bit of code at the start. Now one problem I might have is that this does have a unique ID which can be used for encryption purposes. And yeah, red. Excellent. And verify after was ticked, which I think does a verify at the same time, or is that during programming? Oh, it's come up with a bad block list. That's interesting. Now I have chosen hard copy, so I guess it would have hard copied the bad blocks as well. Let's see what this does. So popping in our new chip, and we'll see how we go. Okay, so I wonder if I should, well, leave this open. We may need to refer to those bad blocks at a later point to try and reread them perhaps. If we have a look at the instructions for using this, it does say to do, if you're trying to copy a chip, you should do a hard copy, so we'll trust that for now. I'm still learning a bit about how bad blocks are dealt with. Certainly when it's being written to, bad blocks should be written to known good locations. If it comes across a bad block when it's writing to it, it should write it to a known good location. But hard copy is the preferred method by the look of it. So here we go. Device, program. We'll just tick erase before, make sure the chip is blank. You can also click on the P up the top, so we'll do that. Program. Pin detection OK, chip erased, and it is now programming, so we'll see what happens. Now you might be thinking, oh, you didn't show us it working when you froze it on the original chip. I don't want to take the chance that any further work forcing it to work will prevent me from obtaining a good copy of it. So work with what we got, and when you're trying to preserve data, take no unnecessary chances. Well, that says successful program. One attached NAND flash chip. Looking at the row of LEDs here, and what we're hoping for is that they don't stay on and that the thing actually boots. So here we go. 3, 2, 1. Holy monkeys, it actually booted! You've got to be kidding. Let's just try that again. Make sure it wasn't a fluke. That's awesome. That is so cool. Well, now we have to make sure that it is running and see that it pairs with the tablet, but otherwise, so far so good. Kind of need a wider field of view here. So we'll unlock tablet. Now I guess down in the bottom corner we see it connect. I can't remember how this goes. So we'll have a look over here. I'll just stick some power on it again. There we go. Wonder if we'll get some lights to show a radio connection established. I think it's a Bluetooth. Bluetooth, yeah. Now we probably find out this is where the encryption unique identifier matters and it won't pair with the bloody thing. That would suck. Okay, here we go. I just tacked on VCI at the bottom. Just tap on that and it come up with paired. So it must be paired. Can we select that? Unpaired. Uh-oh. Pairing. Unable to communicate. Why unable to communicate? Ah. Boo. What's going on there? Let's reboot. Well, if I do a scan, it says no device found. So something's functioning, but obviously some other part of it is not. Wonder what it could be. Perhaps I should throw the old processor back on. So let's have a look at the Bluetooth device that is on this thing. And there's the pinout. It's a little board that gets attached. Well, I'll show you. One Bluetooth device, you can see the pins down the side where it attaches to the board. It's its own little PCB. It's a common way of doing things with little modules. And it's a WT11I-E, so I'm just going to have a look and see if there's any data being or any communication between the processor and this board. On the right hand side in the white you can see where it says wireless, we've got CS1, S-Clock, MISO, MOSI and TXD2. That refers to the gold pads to the right of those as test points. So we can look at that on the scope and just see is there any activity going on there, and also as per the data sheet, which is where'd it go? Pin 17 is reset, so I'll be quite interested to see if that line is active high reset. So according to, there we are, so it needs to be pulled down. It has an internal pull down and internal startup reset circuit, so it must internally hold it high while it starts up and then pulls it low, and then the processor must go high on that line to reset it. So if it's a high, then we know that the processor is not ready to communicate. Just try and rule things out, because swapping the processor back to the original is a hell of a job. There's a lot of little balls under that, and I want to avoid having to deal with a million balls that may or may not connect. Although it must be doing somewhat okay. But I mean, I suppose there's a chance that there's a ball under there relating to Bluetooth that's gone astray. But I'd rather not. I think the next step after this would be to put the original chip back on and freeze it to make it boot, and then just make sure that it does pair, and that will prove the processor's okay, and that'll prove it has something to do with the unique ID of the chip, the NAND flash chip. Or we got a bad copy and maybe we just try again. Prove that again. 1, 2, third one along. Better. It's a lot cleaner looking signal. Well, it is currently low, which is what we want to see because it's an active high reset. So next what we want to look at is what's the clock line doing? It's doing nothing. I bet the other lines are doing nothing as well. It looks pretty dead to me. Oh, and the last line is just fixed high, so 1, 2, 3, 4 TXD2 would be the other line. So yeah, doesn't appear that there is anything going on there. So either two things: it hasn't authenticated properly, or it isn't sitting on the board properly from being replaced. What do I do? Do I put the old NAND flash back on? That's probably the safest way to check that the CPU is firmly attached. Unless of course the processor has something unique about it and I do have to put the old one back on. Alright, let's put the old NAND back on. Okay, so old flash chip is attached, and if I plug it in, you'll see the problem that we have with the old chip. You'll get lights and nothing else. There you go. No booting. And then I will freeze the chip. Although I should probably attach the aerial before I do this, just so we can make sure we can get the Bluetooth signal. Stand by. So, hit it with a freeze spray. Which I'm running out of. Gonna have to do it. And attach the power. What? Maybe it's not cold enough. There it goes, right. Now, hit scan on the tablet. Is it going to work? There it is. Paired. Simple as that. We have green lights. We have a green tick on the VCI icon. So we know that the processor is running okay. We don't want to pull that off the board. But what we do have to do is try and get a copy off that chip that is suitable. Bugger! Okay, so if I pull the power on it, I did notice that it's not beeping as loud as it did. I don't know what's going on there. But anyway, power. No, not going to work. So obviously it has to be quite cold. I'm going to have to I'm going to have to go buy another can of freeze and try and make another copy, see if we can't get the bad blocks off it, or copy it, less the bad blocks, or maybe copy it using a different bad block processing method. Well, I've put some Kapton tape over the pins to try and stop any condensation build-up interfering with the data. Right, let's try this device read ID, and it has read. So let's see, we'll freeze the chip and start reading. Now it does have to be pretty cold from what I gather from the last attempt when it did boot, so we'll go with that. We'll go read. That's reading. And we'll keep it chill. And hopefully we don't get the bad blocks that we had before, or less of them. Here you go, skiing on that field. That's pretty thick. Up to 50%. Done. Okay. Only one bad block found that time. It's a bit more promising, isn't it? And that's been written to a different file name so that we're not overwriting our previous attempts. The capped on tape appears to have done its job. It's looking very dry around the pins, although you can see moisture build up around the grooves there. So but yeah, the pins are nice and dry. Good to know. Now I just have to flush this out again. Okay, we've got the chip in. I've done a read ID. We have ADF1. So it's like a manufacturer's ID for that particular chip. It matches the original chip ID. So this is not the unique ID that's hard coded in there. There must be another command to read that out. But we're hoping that we don't have encryption based on that, so let's write our second attempt to the chip and see what happens. So I got to about, what was that, 65 odd %, and then it went through really quickly, so I guess roughly half the chip is full of code. And it did find 2 bad blocks while it was writing, so we may have to use a different method of bad block handling, because at the moment it's just ignoring it. Powering on. And we'll see what happens. What we're looking for is that cross to turn into a green tick, and that means it's paired. The VCI is the device we're repairing here, so if it turns into a green tick, that means the Bluetooth's now working. Holy crap, it worked! No way! Really? This is amazing. The only other option would be to replace the VCI, which is hundreds of dollars, so you know, yeah, for a few dollars in chips and time, yeah, 150, 160 odd for the programmer, which is going to be a long-term use thing, so you know, we can write that cost off. It works. And just to show, the red light has gone off and we have the light next to it come on when it paired. So if I have a look, oh yeah, looking at the end there, so I've got power on the left, exclamation mark in red, Bluetooth paired on the right of that, and then of course we've got here, what's that, LAN possibly, USB and vehicle connection. So let's go for a drive and prove this works in a vehicle. So here we are in a Mazda RX-8. Got plugged into the port, and we have our power light and Bluetooth paired light And if we look over at the screen, it's a very sunny day here, but you can see hopefully the green tick on the VCI button, which shows that it is paired. So now we just have to confirm communication with the vehicle. It is so hard to get a good image out in the daylight. Alright. Diagnostics. Mazda. Oh, we're still connected. Read vehicle ID. Will it read? I'm going to have to do this in steps to prove it, because I can't show this in daylight and I have to be beside the vehicle and I can't park it under shade. So it has read the ID, but the Bluetooth range is pretty crap and you've got to basically be right beside the module. So we'll OK that. And a quick scan shows no faults on the engine computer, so there's your proof that it works. Well, I hope you all enjoyed that. I'll look into the Bluetooth signal strength, but there is a possibility that the connector on the end of the coax is a bit dicky. Otherwise, it's working. 100%, no problems. Thanks for watching.